All right, so in part 8, we are going to be looking at rational equations and radical equations. So we are going to be using a lot of the same skills that we have been using in the last several videos, factoring and working with quadratic equations, but it will be part of a larger problem. It won't be the whole problem. We're going to be starting out with something like this, where we have fractions, where we have variables in the denominator, and whenever we have a variable in the denominator, or if we have a variable inside of a square root, we always need to think, what can x equal and what cannot x not equal? Can x not equal? So this is kind of the question of the domain of the function, meaning what can the x values be? What can the input be? That's what domain is, the possible x values. And so in this case, we can't ever divide by 0. When we have a variable in the denominator, that gives us a restriction on our variables. So in this first example here, I have x plus 5. Well, the x value that would make this denominator 0 would be negative 5. Negative 5 plus 5 would be 0. And so we know that x cannot equal, that's what this equal sign with a line through it means, it can't equal negative 5. And it can also not equal 1, because 1 minus 1 would be 0. So whenever we're doing or working with rational equations, we always need to think, what would make my denominator 0, and remind ourselves that x cannot equal those values. And then we'll look in a few minutes about what x can equal or not equal with square root equations. Now, there's two types of radical or rational equations that we can look at. The first one is if we just have one fraction on one side and one fraction on the other. If you just have one fraction and one fraction, the easiest way to go about solving this is to cross multiply. So I would have negative 3 times x plus 5, and I would have 2 times x minus 1. So 2 times x minus 1 is equal to negative 3 times x plus 5. From there I can distribute. And I want to get all the x's on one side, so I'm going to add 3x to both sides, and that'll give me 5x on this side, and adding 2 will give me negative 13. So x is equal to negative 13 over 5, and that's okay. X can equal that because it's not negative 5 and it's not 1. If I had gotten down to the answer of x equals 1 or x equals negative 5, then I couldn't have a solution. I wouldn't be able to use those because x cannot equal those values. Now, the other type of rational equation we can look at is if we don't just have one fraction on each side. So I only have one fraction on this side, but on this side I have this fraction, and I also have this other term over here. If you have that scenario, then what we're going to be doing is multiplying both sides by the least common multiple. So, or in other words, the common denominator. And the common denominator here would be x times x plus 1. Okay. Now, that's our common denominator because I need to have a single x by itself, and I need to have an x plus 1. If there was a denominator here, I'd also have to consider it. And I still also have to consider what x cannot equal. And in this case, x can't equal 0, and it can't equal negative 1, because that's what would make these denominators 0. So I'm going to multiply both sides of my equation by x times x plus 1. And I'm going to multiply this side by that, x times x plus 1. And on this left-hand side, when I distribute that to the 5, I'm going to have 5x times x plus 1. And then distributing it to the second term, I'm going to have over here the x plus 1's cancel, and I'll just have 3 times x. On this side, I'll have the x's cancel, and I'll have 4 times x plus 1. From here, we can go ahead and distribute and simplify. So distributing the 5x, I have 5x squared plus 5x plus 3x is equal to 4x plus 4. And since this is a quadratic equation, we do want to set it equal to 0, and I get 5x squared 5x plus 3x is 8x. Subtracting 4x from both sides will be 4x. And then subtracting 4 will be minus 4 equals 0. And like we talked about in the last video, the easiest way to solve a quadratic equation is by using the quadratic formula. So x is going to be equal to negative b plus or minus the square root of b squared, which is 16, minus 4 times 5 times negative 4, all over 2 times 5. And here we have a negative times a negative is a positive. 4 times 4 is 16, times 5 is 80. 16 minus 80, let's see here. Oh, not minus because we're adding them. So that'll be 96. So we have negative 4 plus or minus the square root of 96 over 10. And from here we want to simplify that as much as possible. We can rewrite the square root of 96 as 4 root 6. So this is going to be negative 4 plus or minus 4 square root 6 over 10. And that can reduce. 4 over 10 reduces to negative 2 over 5 plus or minus, and the 4 and 10 again to 2 over 5 and square root 6. Now, neither of these, negative 2 over 5 plus 2 root 6 over 5, and then the minus version of that as well, neither one of those simplify to 0 or negative 1. So those are both okay solutions. So we're going to go ahead and practice both of these methods and on to the next page. And we have a few examples here. So we have one where we're going to use cross multiplying, and then we have a couple more where we're going to multiply by our common denominator. So cross multiplying here, I have 2 times 2x plus 5 is equal to negative 3 times x minus 1. Distributing here, we get 4x plus 10 is equal to negative 3x plus 3. Adding 3x to both sides, 7x, subtracting 10, negative 7, dividing x is equal to negative 1. I need to make sure over here, here I would get negative 5 over 2. And the way you can tell if you're not sure what x value would give you a denominator of 0 is set it equal to 0. 2x plus 5 equal to 0. Subtracting 5, dividing by 2, x would equal negative 5 over 2. And then here, x equals 1. So x cannot equal either of those values. Negative 1 is not the same thing as positive 1, so this answer is okay. The next example is one where we are going to be multiplying both sides by our common denominator because we have two terms on this side, not just a single fraction like we had here. So my common denominator, well, this is a minus 3 and this is a minus 3 and this doesn't have a denominator, so my common denominator is going to be a minus 3. So I'm going to multiply by that on both sides, and a cannot equal 3. That's the only value a can't equal. So I'm going to multiply by a minus 3 on this side, and I'm going to multiply by a minus 3 on this side. A minus 3 times 2 is 2a minus 3, plus a minus 3 and a minus 3 here will cancel, and I'll just have 3. Here they cancel, and I have just a. So 2a minus 6 plus 3 equals a. And I can go ahead and get all our variables on one side and numbers on the other. So negative 6 plus 3, 2a minus 3 equals a. Subtracting, running out of space here. Subtracting this over, I'll have negative 3 equals negative a, so a equals 3. Well, that's the problem. A cannot equal 3. So since it can't equal that, we have no solutions. So that's why it's really important that you make sure what a values you can't have, so that if you got down to something like this and you just said, oh, okay, a equals 3 and you're done, well, you get it wrong then, because a cannot equal 3. Okay. All right, one more, and here we have a fraction here, another one here, and another term on this side, so I have to multiply by my common denominator. If I factor this, I have x plus 4 and x minus 4. And so I can go ahead and find my common denominator. and it'll be x plus 4 and x minus 4. I need to have that for both of those factors here, and x plus 4 is taken care of, and there's no denominator here. So multiplying both sides by my common denominator. Oh, and I also need to make sure x cannot equal -4 or +4. So x cannot equal either of those values. So going ahead and multiplying both sides by my common denominator, x plus 4, x minus 4, and same thing on this side, x plus 4, x minus 4. And on this side, the x plus 4's will cancel, and I'll have x times x minus 4. And over here, both x plus 4 and x minus 4 will cancel, and I'll just have 11 plus 2 times, and there's no denominator here for anything to cancel, so x plus 4 and x minus 4. Multiplying these out, I have x squared minus 4x equals 11, and then this right here is really just x squared minus 16. That's what we saw here. So distributing the 2 to that, I have plus 2x squared minus 32. I want to get everything onto one side set equal to 0 so that I can solve this quadratic equation. So getting this x squared over on the side, adding the 4x, I have 0 is equal to x squared, and then plus 4x. And then 11 minus 32 is -21. This is something that I can actually factor using the x method, or I could use the quadratic formula. I could use whatever I want. So 0 is equal to x plus 7 and x minus 3. So x is equal to -7 and x is equal to 3. And neither of those are positive or -4, so both of those answers are okay. So that's solving rational equations. We can look now at solving radical equations. And again, we want to consider the domain and range of the equations. So if we are working with square roots, we know we can't take the square root of a negative number because right now we're just working within real numbers. And so we want to make sure that we are careful about that. With cube roots, we can take the cube root of a negative number, so that is okay to have a negative inside there. All right, so with these types of questions, it's really necessary for you to check your answer because in the way we're going to solve these equations, we're actually, in some scenarios, going to create solutions that aren't actually there. So it's really important that when we get down to our answer, we plug it into the original equation and make sure that they actually work. So what we're going to be doing here is we're going to try and get the root by itself and then square both sides. So the first thing I want to do is get this square root by itself. So I'm going to add 6 to the other side. And now I can square both sides to undo that square root. So those undo one another. And I have x minus 2 is equal to 36. Adding 2, x is equal to 38. And again, I want to check my answer. So plugging in 38. 38 minus 2 is 36. The square root of 36 is 6. 6 minus 6 does equal 0. So that does in fact work. Looking at the next one, we have the cube root of x plus 2 is equal to -3. I already have the radical by itself, not raising it to the second power here because this is a cube root. So the way you undo a cube root is you raise it to the third power. And whatever you do to one side, you have to do to the other. So those undo one another. We have x plus 2 is equal to -3 cubed is -27. Plus 2, so subtracting 2 from both sides, x is equal to -29. And again, we want to check our answer. So plugging in -29. -29 plus 2 is -27. The cube root of -27 is -3. It does in fact work. Looking at the next one, I have this square root here and I want to get it by itself, so I'm going to go ahead and subtract 4. And I have the square root of 2x minus 5 is equal to -3. Now I can actually stop right there and write no solution because I know that the result of a square root is not going to give me a negative number. But let's just say you didn't know that. let's just say you said, okay, so now I square both sides, and I square this side, and I get 2x minus 5 is equal to negative 3 squared is 9. I add 5, 2x is equal to 14, x equals 7. Well, again, you want to check your answer. So you plug in 7. 2 times 7 is 14. 14 minus 5 is 9. The square root of 9 is 3. 3 plus 4 is not 1. So since it doesn't actually work out, we know that that's not a solution, which means we have no solutions. Again, really important that you're checking your answer. Now this next example is a little bit longer, and the reason why this is going to be a longer problem is because there's 2 square roots. So what I suggest doing here is if we have this small square root here, go ahead and add it to the other side or subtract it over to the other side. And now we're going to go ahead and try and get rid of this square root first. So I'm going to square both sides. But you have to square the whole side. You're not just squaring individual terms. So this will get rid of this square root, and I'll have 2x minus 1. But over here, squaring this, I'm going to need to use a box or foil or something like that. So go ahead and do a box here off to the side. And I have 2 minus square root x, 2 and negative square root x. And 2 times 2 is 4. 2 times negative square root x is negative 2 root x, and negative 2 root x, and then negative root x and negative root x. Negative times a negative gives me a positive. Square root of x times square root of x is just x. If you're not sure why that is, if you think the square root of x times x is going to give me the square root of x squared, and that would just be x. You can also think if I had the square root of 2 times the square root of 2, well, that would give me the square root of 4, which is 2. Kind of works the same way. So I have 4 plus x, and then negative 2 root x and negative 2 root x is negative 4 root x. And now this is the only square root left. So what I want to do is try and get that square root by itself. So I'm going to go ahead and subtract 4 from both sides. I'm going to subtract x from both sides. Those cancel, and I'm left with x minus 5 is equal to negative 4 square root x. And now I'm going to go through that process again. I'm going to square both sides of my equation. And x minus 5 squared, you can use foil, you can use a box. I'm not going to show my work for it this time. X squared minus 10x plus 25 is what you'll get. Negative 4 squared is 16, and square root of x squared is just x. So now we have no more square roots left. I can get my quadratic equation set equal to 0. And I have x squared minus 26x plus 25 equals 0. I can go ahead and use the x method now. 1 times 25 is 25, negative 26. And negative 1, negative 25. Multiply to positive 25 and add to negative 26. So x minus 1 and x minus 25 equals 0. X equals 1 and x equals 25. But there's one more thing I need to do. I need to check my answer. Now, when you have a more complicated equation, checking your answer, you might actually want to write it out or show some work for it because it can be really hard to keep track of your work. Let me go ahead and zoom out a bit so you can see the whole problem together. If I plug in 1, 1 times 2 is 2. 2 minus 1 is 1. The square root of 1 is 1. Plugging in 1 here, plus square root of 1 is 1 equals 2. So this one does, in fact, work out. If I plug in 25, 2 times 25 is 50. 50 minus 1 is 49. The square root of 49 is 7. And then plugging in 25, square root of 25 is 5. 7 plus 5 is not equal to 2. So that one does not actually work. So again, it's really important that you do check your answers. If you got down and boxed both of those and left it just like I had originally wrote it, then you wouldn't get full credit. You do need to go through and see, do both of them work? Does only one work? Do neither of them work? And check your answers. All right. We're now going to look at solving absolute value equations. And solving absolute value equations, in one sense, is a little bit easier because there's not going to be factoring or X method or any of that, but it's a different type of equation. So some of the rules you want to remember with absolute value, if you have two absolute value bars, you can't like distribute into them or anything like that. The first thing we're going to want to do is get the absolute value by itself. Then we're going to write two equations, and then again, these ones are problems where we do want to make sure we check our answers. So the first thing I'm going to do is get the absolute value by itself. I'm going to subtract 3. Again, notice I'm not distributing a 2 in. That's not something we can do with absolute value. Subtracting 3 from both sides, this is going to be 10. I can get rid of that 2 by dividing both sides by 2, and I have absolute value of x minus 3 is equal to 5. My absolute value is by itself now. I can go ahead and write two equations. For the first equation, you just remove the absolute value and solve. So just removing the absolute value, I have x minus 3 is equal to 5. For the second equation, you're going to remove the absolute value, and you're going to multiply the other side, the one that did not have the absolute value, by negative 1. So negative 5, or 5 times negative 1 would be negative 5. Now, the reason why I say multiply the whole side by negative 1 is because if I had 5 plus 2x or plus something else, the whole side would need to be multiplied by negative 1, not just the number. So going ahead and solving these, x minus 3 equals 5. Going ahead and adding 3, x is equal to 8. And adding 3, x is equal to negative 2. I get both of these answers. I need to check both of them. 8 minus 3 is 5. Absolute value of 5 is 5. Times 2 is 10. 10 plus 3 is 13. That one does work. Plugging in negative 2. Negative 2 minus 3 is negative 5. The absolute value of negative 5 is 5. 2 times 5 is 10 plus 3 is 13. They both work out. For the next example, I have x plus 1 plus 6 equals 2, and I can go ahead and subtract 6 right here. And I have x plus 1 is equal, or absolute value of x plus 1 is equal to negative 4. And right there, I can go ahead and write no solution. And the reason why is because the result of an absolute value can't be a negative number. Now, you can't make this conclusion until you get the absolute value by itself. But when the absolute value is by itself, there's nothing else on this side, there's no negative out front or anything like that, and that's equal to a negative number, you can go ahead and write no solution because you can't get a negative result from absolute value. All right, now the next type of equation we're going to look at, and this is going to be the last type in this video, is compound inequalities. So we're going to look at compound inequalities as well as absolute value inequalities. And we're going to be looking at the difference between the word and or. And so this is going to probably kind of send you back to the first couple of videos when we talked about the union and intersection of sets. And is like the union, or I'm sorry, the intersection, or is like the union of sets. So intersection, meaning it needs to be true for both of them. Union is either one, or like kind of squished together was the term that I used in those videos. So here I have negative 1 is less than x, or in other words, x is bigger than negative 1, and x is less than or equal to 3. So I think it's helpful to look at them separately first. So if I have negative 1 and I have 3, this will be a closed dot because it has the line underneath it, and x is less than 3, so shading this way. Here, x is bigger than negative 1. It does not have the line underneath, so it'll be an open dot and shaded this way. We want this true and this true, so that means we're looking for where it's overlapping. So my answer would be from negative 1 to 3. Closed dot at 3 and an open dot at negative 1 because it's not equal to negative 1 on both of them. And then we can go ahead and it'll just be this one and this one here, and then it'll be shaded in between. And if you wanted to write that in interval notation, that would be -1, 2, 3 with a bracket on 3 since it has a closed dot. All right, and then we can go ahead and the next one is very similar, and we have x is less than -1, so let's go ahead and graph them separately first. And it says or. Now, these graphs are not corresponding to the words and or. So it's saying we want either one of these to be true. They don't both have to be true. So what we're looking at here is squishing them together. So if you recall back to the video where we did the union and intersection of sets, this is like squeezing them together. So if I were to squish these together, I would have an open dot, a closed dot, shaded this way, and then that would be these two intervals. And so we have from -infinity all the way to -1, and then from 3 to infinity. So it would actually take me 2 intervals to show this. And so that's how you would write it in interval notation. Now, sometimes we're working with these types of problems and we're working with it with absolute value as well. And these are the rules you're going to need to follow for writing absolute value inequalities as 2 separate inequalities. So if you have the absolute value and it's less than C and less than or equal to C, then we have, or if you have the pointing towards it, it's going to be different to write them these 2 different ways. So you'd write it like this, or you'd write it like this, depending on whether it's pointing to or pointing away. So for these examples here, let me get that light out of the way here. We have this first one here. And the first thing I want to do is get the absolute value by itself. So I have -9 and -9 here, -3 and absolute value 2x plus 6 is less than, and that'll be -24. And one thing you want to remember here is whenever we're working with inequalities, if we divide both sides by a negative or we multiply both sides by a negative, you flip the direction of the inequality. So here I'm going to go ahead and divide by -3 to get rid of that. And I'll have the absolute value of 2x plus 6. And then I'll flip the direction of my inequality. A negative divided by a negative is a positive. 24 divided by 3 is 8. So now that my absolute value is by itself, I can go ahead and write my 2 inequalities here. And then I can go ahead and follow those rules that we just talked about. Actually, let's see if I can fit both of these together here, just so you can reference them. All right, so notice here we have the inequality is pointing towards the absolute value, so we're going to be using these 2. And then I have without the line underneath. So it's going to be following this kind of pattern here. So I have 2x plus 6 is less than -8. So switching that sign of that C value, notice the negative there. Or, and it's really important that you include the word or here because it does make a distinction, or it does make a difference. 2x plus 6 is greater than 8. So notice that this one is just keeping the same exact thing here, pointing towards it, +8, everything is exactly the same. We just took away the absolute value. This one, the inequality flipped directions, multiplied by a negative, no absolute value anymore, and we're using the word or. So now I can go ahead and solve both of these, and I can go ahead and subtract 6. I have 2x is less than -14, and then x is less than -7, and then subtracting 6, 2x is greater than 2, so x is greater than 1. And again, we're remembering the word or here. So I can go ahead and graph both of these. I'm going to graph them again like I've been doing, one over the other. And then 1. They're both open dots. And x is less than -7, so shaded this way. And then x is greater than 1, so shaded this way. So when we say the word or, what we're saying is that we want this or this. It doesn't have to be both of them. So again, the word or is meaning like we're using the word or using the union symbol. So it's like squishing them together. So my graphical answer here would be -7, open dot here, shaded out here, and then we want to write it in interval notation. This is a 1, so that would be -infinity to -7, and then 1 to infinity. All right, so we have a couple more here. And we have x plus 11 is less than 19, and it tells us the words now. So that first one was the absolute value inequality, where we had to determine whether it was and or. These next several examples tell us whether we're using and or. So we can go ahead and solve each of them. Subtracting 11, I have x is less than 8. And then here, if I add x, I'll have 4x is greater than or equal to 4, x is greater than or equal to 1. And I can go ahead and graph both of those separately. So 8 and 1. This one will have a closed dot. This will have an open dot. X is less than 8, and x is greater than 1. And this uses the word or. Now, or means either one of them. So this is the squishing them together. And if I squish these together, the whole number line is shaded, and that would be -infinity to +infinity. On a quiz or an exam, I would want to see both of those, so make sure that you're showing the graph and the answer written in interval notation. The next one has the word and, so you want to make sure that we're saying both of them are true. So we want where this is true and where this is true. If I add 3 of x less than 5, and dividing by a -5, remember anytime you divide an inequality by a negative, you have to flip the direction of the inequality. 15 divided by -5 is -3. So we can go ahead and graph those two separately. 5, open dot, -3, also open dot, x greater than -3 and less than 5. We want where this and this are true. So that would be where it's overlapping. So my answer then, my graphing answer is -3 to 5, open dots of both of those shaded in between, and then my answer would be -3 to 5 in interval notation. 2 more. Next one, going ahead and subtracting 7, x is greater than 13, and adding 2x here, we have 8x is less than or equal to 2, dividing by 8, x is less than or equal to 1/4. And it doesn't make it any harder that this is a fraction. We just need to know that 13 is bigger than 1/4 when we line up our graphs here. So I have 13 would be an open dot, x is bigger than 13, and then 1/4 closed dot because of the line underneath, and x is less than that. And it says the word and, so we want where they're both true. But if you look at these graphs, there's no overlapping area. There are no numbers that are both bigger than 13, but also less than 1/4. That doesn't exist. There's no numbers that satisfy both this and this, which means that my graphical answer here will be an empty number line. There's nothing there. And written in interval notation, that would be the empty set. I would want to see an actual empty number line on a quiz or an exam. One more example, and that'll be the end of part 8. So adding 3 here, I get x is greater than -10. And then adding 2x, I have -x is greater than or equal to 14. And then dividing by a negative, that flips the direction of my inequality, x and -14. All right, so from here we can go ahead and graph both of these separately. -10 negative 14, close dot, open dot, x bigger than negative 10, and x is less than negative 14. It says or. This is an or inequality, so it can be this or this. Squishing those together, and negative 10. And then my answer would be negative infinity to negative 14. Oops, that should be a bracket because it's a closed dot. And then negative 10 to infinity. All right, this was a little bit of a longer video, but that gets us to the end of part 8 and looking at all those different types of equations.